Hi, I'm Evan, and today I'm going to talk a little bit about my virtual instrument Anukari. About 6 months ago, I did a demo video of the initial prototype of Anukari and went into what it was capable of at that time. But in the last few months, I haven't really talked about it much. I've released a few demo videos, really short things, just showing off kind of weird, funky ideas I came up with using Anukari. But most of it was free of any kind of real explanation, and I think it kind of left people with lots of questions. So I'm here today to answer a lot of those questions, or at least I hope so. I'm going to do a really detailed walkthrough of what Anukari is, what it's capable of, how you use it, especially how the user interface works, how you interact with it. This is still a really kind of early video. There's a ton of work to do to make Anukari usable, fun to use, I guess. But it's pretty workable today. Like, it can do a lot. It's not really capable in the way that I want it to be, but I'm still excited to show off what it can do. Before I go into the details, I just want to say thanks to everybody who's been following along, providing words of encouragement, especially people who are asking questions, giving me feature requests, telling me about their ideas of what they might use Anukari for. All that stuff is super helpful while I work on it. Leaving YouTube comments is a great way to get in touch with me. Also, my favorite way is that we have a Discord server that people can show up on, and there's often super lively discussion about Anukari and other sort of related types of synthesizers. So anyways, thanks for everybody who's been following along, and I hope more people come talk to us. So just a really quick sort of reminder of what Anukari is. Anukari is, I guess you could call it a physical modeling synthesizer. It models masses and springs and then a few other types of physics objects that interact with them. It is a physical modeling synthesizer, but it's actually, substantially different from most of the physical modeling synthesizers out there today. The way that Anukari works is it takes this big system of masses and springs and other stuff, and it runs a physics simulation much in the same way that like a video game would run a physics simulation. The big difference between Anukari and a video game is that Anukari is running that physics simulation, taking snapshots of the state of the system at 48,000 samples per second, or whatever your audio sampling rate would be. Whereas the video game engine only needs to do it at something like the frame rate, maybe 60 frames per second. It could be higher, maybe 100, 200, but definitely a couple of orders of magnitude slower. But that's sort of what Anukari is doing, and it's why it's a little bit different from traditional physical modeling synthesizers. Although, because it is modeling a physical system, I think that's a perfectly valid term for what Anukari is doing. So anyways, got a lot of questions about the user interface, so I'm going to show that off first. So if you right-click in the user interface, you get this menu. And this is the menu that lets you add different types of entities in the world. So you can add an anchor. That's where I'm going to start. I'm going to add another anchor. So these anchors, these little black things, these are fixed objects in the world. They tie things down. You use them to tie down a system that's dynamic. So then we create a body, and the bodies are sort of the free things that can move around. And then I'm going to connect that body to the anchors using springs. And notice, bring up this menu. There's hotkeys or shortcuts for all these things. So you can create a bunch of anchors, a bunch of bodies. It's much easier to do using the keyboard shortcuts. But for this video, I'll try and use the mouse stuff as much as possible because I think it makes it easier to see what I'm doing. Anyways, now that we've added a mass and 2 springs, now we have a system that can vibrate. So I just, what I did there is I pulled the thing back with the mouse and released it. And because it's attached to these anchor points with springs, just naturally it's going to vibrate when I do that. Another thing is that doesn't make any sound. And the reason for that is that I haven't introduced a microphone. So I'm going to create a microphone now. That's this thing. I kind of move it over here. Maybe move it here and rotate it. And so still there's not going to be sound. And the reason for that is that in Anukari, you have to tell the microphones which things they're connected to or which things they can pick up sound from. So now I've connected the microphone using this pink thing. Using a sync connect to. In this case, you get a little pink connection instead of a spring because it's a microphone. And now we have sound. Okay, it's kind of a very loud, deep sound. I'm going to make the spring a bit tighter. So springs have 2 parameters. There's the stiffness of the spring, and then there's the length of the spring. So the length of the spring is the natural resting length of the spring. Like if you took this spring apart set it just on a table on its own, not connected to anything, this is the length that it would want to return to. It's the neutral length of the spring. And the stiffness is if you pulled or pushed on the spring, it's how much that spring wants to resist that motion. So if we make the length, okay, there's a lot of gain on that microphone. If we make this springs longer, it'll push things away or pull it in. Okay, let's remove a lot more gain from that microphone. But yeah, so as you can tell, the length has a lot to do with the sound. Okay, I'm going to take even more gain off that microphone. So here, I've set the length of the springs to be pretty long. And so it doesn't come pull back to the center here because the springs are actually too long for that. They kind of stick out. And you get a totally different sound from longer springs like that. Ooh, little crazy sounds. So, okay, let's make them sort of more normal-ish springs. Oops, had this selected. Okay, and then let's just play with the stiffness of the springs. So as you can tell, stiffer springs have higher pitch. And looser springs have lower pitch. Okay, so that's kind of what the springs do. Now the body itself has 2 parameters. So if we look at the body, it has mass. And the mass affects things a lot the same way that the stiffness of the springs does. More mass, making this thing heavier, means that you're going to get a lower pitch. And less mass means a higher pitch. And then damping is how quickly the vibrations die down on their own. So right now you can hear it rings for a while after I release it. If we give it a lot of damping, it dies down really quickly. A huge amount of damping, almost more of a click. And then if we release the damping a lot, we can get it to ring forever. It'll just keep going and going. I'll put it somewhere in the middle. So it's fun to interact with Anukari using the mouse this way, kind of plucking things. Has a lot of flexibility, and I think that you really could perform with it this way. But a lot of the time, you want to be able to connect it to like a MIDI keyboard and play it more like a musical instrument. So I'm going to add an exciter. So an exciter is this generic term for anything that introduces energy into the system. Bangs on the system, plucks the system. However it introduces energy, it vibrates the system. That's an exciter, and there's a few different types of exciters. So the first one is this mallet. Like the microphones, you have to connect the exciter to the system to tell it what it's going to, apply a force to. So we're going to have it apply a force to the free mass. And also, like the microphone, the exciter has a direction. I didn't show this before much. So dragging this thing around moves it, same with the microphone. We can click this little button up here to get into rotation mode. It shows these little cages, and now dragging it changes the orientation. So I'm going to point the mallet at the mass, but you can point the mallet any direction you want. It doesn't have to be pointed at the thing. The direction of the mallet is the direction in which the force is going to be applied. Now with the microphone, the direction affects the loudness of the microphone relative to what it's pointed at. So if I point this microphone away, let's turn the damping down a bit. Kind of a subtle thing, but you could hear the volume got down as I pointed the microphone away, and the volume went up as the microphone got pointed more towards the thing. The other thing to mention about microphones is that their orientation relative to the object that's vibrating matters. And what's happening is that the direction of this pink line, that's the direction along which the microphone is going to pick up vibration. So if we pull this back kind of along that line and this axis, we'll get that sound. But if we pull it sort of like, not on that axis, you get a different sound. I don't know if you could hear that. So it's kind of a more pure wave. And then here we get something a little bit different. And this is a really simple system with just one free mass. A lot of the subtle stuff that you can get out of Anukari is using lots of masses. But even with a simple system, you can hear that the direction of the microphone and its orientation relative to this thing matter. So anyways, going back to this exciter, we've got this mallet and it's connected by default to C4. So if I press that, the mallet makes a sound. It's got a few parameters. Right now it's pretty quiet. So I'm going to adjust the impulse higher. The impulse is how much energy it introduces. And so the way the mallet works, the physical model for the mallet, is that it applies a really brief force to the object in the direction of the mallet. So in the direction of this green arrow. So if I point that force kind of more like in the same direction as this pink line, the microphone axis, we get one sound. And it's kind of a louder sound. And if I point it, maybe a little bit differently, something that's kind of off kilter, we get a different sound. You can kind of hear more of like a sort of a pitch distortion happening there. Not a pure sine wave anymore. So we'll go to something a little bit in between. So other parameters. So there's a hardness setting for that model. Then the hardness is related to the duration over which the impulse of the mallet is applied to the object. So I'll make the max velocity hardness high and the min low, which means if I hit the MIDI key with a lower velocity, it'll be softer, and a higher velocity will be harder. That's kind of low velocity. It's hitting it really hard. You can see it's moving across the screen a lot. And another parameter we have, I'll kind of make the velocity a little bit more normal. The other parameter we have is noise. So it's a little bit hard to hear, but you can hear a bit of a click at the start of the attack. And that click is the result of a certain amount of noise being introduced into the force that's applied to the thing. If you turn the noise all the way down, you don't get much sound. You can if you crank the impulse up, but somewhere usually in the middle, a little bit of click gets a kind of more of a melody sound. So yeah, that's the mallet. Most all objects in Anukari have a few other editable parameters, just in terms of their position and their orientation. These are generally easier to edit through the 3D part of the user interface, but sometimes for really precise measurements, you might want to type in exactly 0 latitude, 0 spin to get it exactly on some axis. So those are there for that. Next, let's look at we're going to skip the audio input for now. Let's look at the oscillator. Okay, so the oscillator needs a little bit more gain. I want to hear a little bit. Let's turn up the gain on the microphone, actually. And actually, one thing I should show here in the user interface is if you select multiple types of objects, you can get all of their properties visible at the same time, or however you want it. So here we have a microphone and an exciter selected. And this is useful if I'm trying to set up some parameters that kind of need to be tuned in a certain way between two things. So now if I want to turn up the mic gain, I can do that here. And then I could turn this gain back down or change the shape of the oscillator, whatever. So it's kind of a handy feature is that you can see the parameters for multiple things at one time, so you can tweak them without having to keep going back and clicking on things. Anyway, so now we have the oscillator working, which is a basic C. You can change the shape. So it's a sine wave right now, sawtooth, rectangle, white noise. So already there's something interesting happening here. So this is a white noise oscillator, which is just kind of, that whooshing sound, which we can hear. But more of what we're hearing is actually this ringing pitch. And that ringing pitch is not coming from the oscillator. So what's happening is the oscillator applies a force to the object it's connected to with the white line. And it applies that force in the direction of the green arrow, the direction that the oscillator is pointed. And that force, the amplitude of the force is, that in this case, white noise, it's random, or it's a sine wave or whatever you told it to be. But after it applies that force to the body is just out there being simulated all the time. And so if you jiggle the body around randomly, eventually it's going to have enough energy to just start ringing at its natural mode of oscillation. So a really cool thing with these white noise oscillators is that you can get things like this, sort of like a pan flute sound, right? And if we wanted to adjust the pitch of that, we could use the mass. Or we could adjust the spring stiffness. We could adjust the length of the spring. We get some weird sounds out of it. Let's get some more damping. So yeah, if we go back to something like the rectangle wave, you can hear the rectangle wave in there, and you can hear it at the pitch we set it to. We can adjust the octave. And you adjust the semitone. All the normal stuff you would expect from a more or less analog oscillator. Another thing about the oscillators and some of the other exciters is that it has an envelope. So you can make it have a really short attack and release if you want. Or we could make it sort of more of a sweeping thing with a long attack and release. Just keeps going. Yeah, and like other things, they have position and orientation editable. Let's look at the bow next. So the bow is an interesting thing. It's a very simplified version of a physical model of a real bow. And sort of the thing that real bows do at the simplest level is that when they're moving across a string, when that string is moving in the same direction that the bow is going, they tend to amplify that movement a little bit. And so as you're dragging it across the bow, when the string is coming, pulling the same direction that you're pulling the bow gives a little oomph in that direction. And so that's what this bow is doing. Let's turn down the gain a little bit. So you can hear what's really happening is that the bow is drawing out that natural mode of oscillation of the system. We can change the pitch here by changing the mass. Now, in a system like this with just one mass, just one mass attached to a couple of springs, the bow is not a super interesting thing because the natural mode of vibration of that system is really mostly like a sine wave. I say mostly, and that's because this is a three-dimensional simulation. The mathematics behind a spring mass model, along a single dimension, it's a perfect sine wave. But if you look at it in 3 dimensions, when we're not necessarily pulling and pushing the spring right along its axis this way. We might be doing it this way. Now there's angles involved, and the angle of the spring matters a lot because the spring's pulling in a different direction based on where the body is. And so you may have heard in some of these demos a little bit of pitch distortion, and that's often because when it's vibrating violently, the force ends up being a very nonlinear thing, and you get outside of the sine wave stuff. You get into this more interesting sounds, but even then, with a single mass, the sounds you're going to get are just not that complicated. And especially with the bow, which just brings out the natural modes of oscillation, you don't get many complicated sounds. Maybe later I will show a demo attaching a bow to a more complex system where you can get more interesting sounds. But for now, it has some parameters around the velocity of the bow, how loud it's going to be. And then the envelope. And there's some parameters around the rosin. These parameters are not super interesting right now, especially with a single mass system. So I'm not going to go into them in a lot of detail. In the future, I may work on the bow model further, but you can get some pretty interesting sounds with it. It just takes a little bit more setup and work than the other exciter types. Okay, now I'm going to look at the plectrum. The plectrum is really simple. We've been having fun just moving this thing with the mouse. I'm going to decrease the gain here a little bit. And the plectrum is just sort of a way of automating that. So if I press the C key on the keyboard, It's a little bit hard to see, but let's look at the distance and duration of the plectrum. So the distance is how far it's going to move the mass. It's going to pull it back a certain distance in the direction that it's pointed, and it's going to then release it and just let it vibrate. And the duration parameter controls how long it takes for it to pull it back and release it. So if we set the distance to something much larger, it was really small before. You can see it moves a little bit more. It'll be much more obvious what's happening if I set the duration to something large. So you can see it's just pulling it in that direction and releasing it. If I change the direction of the plectrum, it pulls it in that direction and releases it. And again, notice the different direction gets quite a different timbre out of the sound. All right. Let's take a look at the last audio input. This is the audio input, this little cone thing. So what the audio input does is a lot like the oscillator. So the oscillator is applying a force to the mass it's connected to, or multiple masses it's connected to, in the direction of this arrow. So is the audio input, but that force, instead of being a simple waveform, is derived from just an audio signal. So right now I have my guitar connected. Looks like we need some more gain. All right. So I'm using Ableton right now with Anukari. And right now this is a partly dry signal. We can hear some of the dry signal as well as the Anukari signal. So what you heard there is when I hit that D on the guitar, I don't know if you can see the neck, the system resonates. That must mean that the system is maybe close to a D, or let's see. Oh, it's close to an A. Let's hit that. Oh, okay, so probably D, which is the fourth, and then maybe E. Oh, not so much E. So this really simple system that does have like a pretty simple mode of oscillation at, I guess, A. It's sympathetically resonating with the guitar. So some of the places we play the guitar are making it louder, and some are not really resonating quite as much. So let me take out the guitar signal, the dry part. Here's just the signal processed through Anukari. So that gives you a sense for what the audio input does. I'm going to go into more detail about that with a more interesting demo a little bit later. Okay, so now we've looked at all of the different types of exciters. We've looked at microphones, and I'm going to just show a little bit more about the user interface here before I go into some of the other entity types. So like any good user interface in this day and age, it has undo and redo. So I'm using hotkeys to create some objects, and then I can, with keyboard shortcuts or through the menus up here, I can undo and redo those things. So this is really important. The undo and redo works for all of the parameters. So if I change the gain here, I can undo and redo that. Yeah, so that all just sort of behaves how you would expect it to. Let's see. So you can select entities using the mouse either by clicking on them or dragging a box. One of the things you can do is kind of like maybe Photoshop or other things. If you hold Control, you can remove things from the selection. And if you hold Shift, you can add things. So this is helpful when you're trying to move part of the system around, but not the whole system. So just, kind of general user interface stuff. One thing that I haven't shown is, let's let this kind of oscillate on its own a bit. You can pause the simulation. And this is sometimes handy, particularly if the system's vibrating quite a lot. And you want to grab something, it's moving around and everything, and it can be hard to get at it. You can pause the simulation, make some changes, adjust it, unpause, let it keep going. There's some other controls up here. You can reset the system to sort of its initial conditions. In a system this simple, that doesn't really matter. But when you get more complex systems, sometimes you just want to reset them to how you had them before. I won't go into these other things too much. Yeah, the camera controls. So you've seen me moving around the camera a lot. So this is just me dragging the mouse with the mouse key held down to rotate. If I hold a keyboard thing, I can move things this way. You can also use the arrow keys on the keyboard to move around like this. If you double click something, it focuses it. So you can kind of come over here and work on this. The mouse wheel zooms in and out. And the mouse wheel also, if you're dragging around an object, you can pull it towards you, push it away using the mouse wheel. So one thing that's really helpful is there's a grid snapping mode. So right now everything can be moved wherever you want it. But if I put it in grid snap mode, it'll snap it to this grid. And the nice thing about that is if you look at the system, it's kind of a little wonky. It's not very symmetrical. If I snap these things to the grid, I can get it kind of perfectly, that must be a half. Yeah, perfectly lined up. And there's multiple grid settings. You can make sort of a finer grid if you want a little bit more control, and then a really fine grid. But mostly if you use this big grid, you can get things lined up perfectly, which is kind of helpful for some types of instruments. Although sometimes it is just really nice to have the instrument be asymmetrical and weird. There's different camera modes. So right now the camera's in focus mode. So whatever entity is highlighted or wherever that sort of three-dimensional cursor is, it rotates around it. And I find that this is the most useful camera mode most of the time. But there's also a free look camera mode. So I'm using the hotkey here, but you can also click focus mode to 3D mode. And this is kind of more like it'd be like a first person video game. You can fly around and, you look around from a first person perspective. With bigger instruments, this can sometimes be handy to get into some small detail. And then we have some orthogonal camera modes. So this is a straight down camera, I think, or maybe it's straight from the left. We have this one, this must be straight down, and then straight from the other side. And so these can be handy if you're trying to make sort of a regular grid of things. And you want them to be lined up a certain way. These different camera modes can be helpful for that. With the 3D mode, it can sometimes be a little bit harder. Like here, I can come down from the top, maybe move this out of the way, select these, shift them over here. Okay, that's more where I wanted them. Put this back. Yeah, so those are different camera modes. And most of the time you don't have to use all of the different camera modes, but sometimes, especially for just more complex instruments, they can be really helpful for getting things positioned exactly how you'd like them. Yeah, let's see. Okay, so there's copying and pasting. That's really important. And there's kind of a subtle thing about how it works. So if I select one entity, I can copy it, and then I can paste, and it does what you would expect. That's also true if I select a couple of things. First, I'm going to select just these two masses in the spring. So instead of just copy and paste, I'm going to duplicate, which is just like hitting copy and then paste. And those moved up above. Now, so the subtle thing is, notice that it duplicated the things I selected, and they're not connected to anything else. The reason it worked that way is that I selected these three entities, and I did not select these two springs. If I select these two springs, and I'm going to pause it, because what it's going to do with a physics simulation is a bit funny. If I duplicate that, then I get the whole connected thing. So the way you select things is really important for what you're going to get when you paste. And this is useful because sometimes you do want to just create another one of these subunits. You don't want it connected to anything. And other times you might want maybe this side to be connected or just this side to be connected. Oop, I selected all three things, all four things. But yeah, so you get the flexibility to do what you want there. Now, before I unpause it, I think I'm going to add a little cross member here. And then, yeah, see, the funny thing is that it's now sort of relaxing into whatever its natural resting state would be, which is not necessarily the state that it was in when I created it like that. Yeah, so that's duplication. You can duplicate big things. Anukari supports right now, hundreds, almost, close to 1,000 physics objects. If you start creating close to 1,000, it does start to slow down. So it's kind of pretty important that you keep things within the right limits. But a system like this is perfectly functional. Snapping to grid is still on. Let's turn that off. And then I can undo all that. So that's a camera. Some of the other stuff I might show, I guess I don't really have to show it. I'll just talk about the fact that you can, saving and loading, that all works right now. You can save to disk and load presets. In this menu, let's continue without saving. It works all how you would expect. And you can actually import other things. So if you have another preset, but you'd like to combine it with this one, let's maybe find something simple. What would be compression test? If I import this instead of opening it, it'll just bring that other preset into this world. And so the nice thing here is if you create little sub-objects that you find useful, you might want to combine them in different ways. You just save them and then you can import them into other presets. That's pretty handy. Okay, so we've looked at some of the basics of the user interface. We've gone into a lot of detail on masses and springs and the different exciters and microphones. The last thing I'm going to go into a lot of detail on is modulation. So I'm going to come in here and I'm going to create a modulator. Create. Okay, so you see this little thing, kind of looks like a knob maybe. And in fact, that's what this one is. This is trying to represent a knob. Again, these graphics are all provisional. Eventually I'm going to pay somebody, work with somebody who actually knows how to make 3D models, unlike myself, make these look cool. But for now, hopefully we can all tell that that's a knob. And I've connected it to MIDI controller number 1. Come over here on my keyboard. And now that knob turns when I turn the knob on my MIDI keyboard. I don't know if you can see that really well. So to make it do something in this world though, we need to connect it somewhere. And so again, like the microphone or the exciter, we connect it. I'm using the hotkey, I'll show with the menu. Connect it, and in this case, let's connect it to this mass. And I'm going to turn this exciter back into something a bit simpler. Let's use an oscillator for now, because then I can get some sounds out of that in a really easy way. Oop, we need more gain. Oh, let's get the mic gain cranked up again. That was really low. Okay, and then I'm going to set a long release. There we go. Okay, so we can make some sound really simply. Okay, so the modulator, up here, when I select the modulator, we can change its parameters. So the position, that's not very interesting. The MIDI control number, that's more interesting. But we connected it to this mass, and that says that we want to modulate something about this mass. We actually select this connection to change what it modulates, the target of the modulation. So right now it's set to position. That's not going to work because this is a free mass. It does whatever it wants according to physics. Let's change it to mass. So this now means that this knob, when we turn it, is going to affect the mass of that body. So let's see if that does anything. We don't hear much. Let's maybe change this to a white noise. Okay, we can hear a little bit there. Let's change the depth. We're going to increase the depth. This means that when we turn the knob, it'll affect the mass even more. Let's try that. Okay, I think we've created a slide whistle. Okay, so that's working. Let's see. Let's change some other stuff. So we have this knob, and like any of these other objects, we can connect it to multiple things. So I haven't shown this before, but the microphone can be connected to as many things as you want to connect it to. Same thing with the exciters. All right. Well, that was quite interesting. Not what I expected to happen. What's happening there is that the the gain on this oscillator is really high. And these masses that we created all had sort of a default mass. They were very lightweight and had very little damping. And so let's try that again. Okay, that makes a little bit more sense. I think now the springs need to be shortened. Let's turn that gain down a bit. Okay. Anyways, that's just a demonstration that you can connect these things to as many objects as you want. And the same is true for modulators. So let's go ahead and connect this one to this anchor point. Now on the anchor point, setting the position X, Y, or Z actually is going to work. So let's turn that knob. So now we've set it to modulate the position of that anchor. Let's actually increase the depth there a bit. Let's play a note. Okay, I'm going to disconnect this stuff so I can turn the gain back up on the microphone. Okay, and what else could we modulate? We might want to modulate the, let's say the detune, or the frequency for that oscillator. Let's modulate that a lot. We're using a white noise oscillator though, so let's go change this over to maybe a rectangle wave. All right, now that's a rectangle wave, maybe we could modulate the pulse width. Let's change that back to a reasonable value. So kind of what you would expect to happen. The main thrust here is just that you can connect these modulators to as many things as you want. And instead of having like this like big table of information showing the modulation matrix, it's just all in this 3D interface. You connect it to whatever you want to modulate, and you set the target parameter, let's say in this case rotation, and then one modulator can change a lot of stuff. And the modulation matrix is really just these green lines, so you can see what it's connected to. And then it can change lots of parameters at once. So this is the simplest modulation, just a MIDI control. But now let's change it to a low frequency oscillator. Okay, so now instead of a knob, we've automated the knob, we've made an LFO. Here it's a sine wave, the frequency is kind of high, so let's slow that down so it's a little easier to see what's happening. And you can see this little gear is animating the waveform of the LFO. And then those same modulation matrix things, these little green lines, are applying all those same modulations now, but they're doing it through the LFO instead of the knob. So let's go back to white noise here. Okay, we can speed that up. Kind of an interesting sound. Another thing about modulators is that you can connect modulators to other modulators. So I'm going to just duplicate this one. And let's see. So this is now modulating the depth of the other modulator. So I'm going to decrease that frequency. Let's maybe make it, there we go. So we're now modulating the depth of the first modulator with the second LFO in a sine wave. And so now we're getting this. Let's see, what else might we want to modulate? Yeah, we can always add another modulator. We can use a knob, and we could attach it to this thing. And here we could change the frequency of the second LFO using MIDI continuous control 1. And we'll make it so it adjusts it by a fair amount. Let's try that. So you can see as I adjust that knob, we get different sounds. Now I'm going going to turn this knob into a low frequency oscillator. And we're getting some quite complex waveforms here now with multiple stacked LFOs. But I'm going to do something incredibly chaotic. And I'm going to connect this first modulator as the input to this third one. So modulation in Anukari can be totally recursive. So eventually, these graphics need to be updated. These green arrows have a direction. So this modulator is changing the depth of this modulator, which is changing the frequency of this modulator, etc. And you can get all sorts of really complex behaviors out of that. Now I'm going to pause the simulation, and I'm going to disconnect this thing because I want to show, I'm going to disconnect actually all three of these. I want to show one more cool feature. So let's change this oscillator back to being like something with a pitch. Let's have this modulator affect its frequency. So the thing I want to show here, let's increase the damping here a bit. The thing I want to show here is that the LFOs in Anukari don't have to be low frequency. They can be really high frequency. So here we have an LFO operating at 7.5 kilohertz. And it's modulating the frequency of this sawtooth wave. And so what we have here is a complex recursive FM operator. And we're getting some odd sounds out of it. Okay, so I'm going to get rid of these chaos machines. And let's go add another modulator really quickly. Let's change this to LFO, and let's just show off the other waveforms. Let's see, let's set this to position Y. Slow it down a bit. Okay. Let's go to 1 hertz. And yeah, so we have sine wave, we have sawtooth wave. This is going to introduce a bunch of energy to the system because it's essentially going to teleport the mass. So teleporting that mass, again, is not something a normal physical system could do. But, we can do it because this is virtual. We could do a rectangle wave. We could do sample and hold. We do white noise. White noise for position of an object is a kind of chaotic idea, but why not? Okay, so those are LFOs. I think that covers most of the stuff that they can do. Now let's actually try and create an instrument, right? So far I've just been kind of demoing weird stuff, but I haven't been trying to make an instrument that sounds cool. It kind of sounded cool, but it was kind of chaotic sound effect kind of territory. So let's make a guitar processor. See if we can have something that sounds a little bit more interesting. So I'm going to delete all this and start over. And let's see. So I'm gonna start using hotkeys just to make this go a bit faster. So instead of coming in here and adding an anchor, I'm going to use the hotkey for that. And let's see. So let's create this anchor, and then let's create a little kind of string of objects. Oops. That here. Okay, then let's turn this one into an anchor. Okay, and then I'm going to string these together. Oops. Now, one thing I should mention, I talked before, the user interface is not at all done. One of the things that I want to do to make this user interface a lot better is add what I would call a duplicate mini feature. So before I showed, you can come in here, go to the duplicate menu, get a copy. And if you want a lot of stuff, you can kind of keep doing that, right? You can just duplicate the duplicates, and now we've got a lot of things. But that's not super convenient. It's kind of workable for right now. Eventually, you're going to have a menu that you go into. You select something. Oops, I plucked it. And you go to duplicate many. And the idea is there is that it'll bring up a menu, and you can say things like, I want 10 copies of the selected object. But also a few more sort of editable parameters there. I want 10 copies of this object and I want them in a circle. Or I want 10 copies of this object and I want the stiffness of the springs in each one to be increased by 10%, or whatever. And the idea is that menu would give you a lot of flexibility over creating much more complicated objects, because, this supports hundreds of these masses, thousands of these masses eventually, I hope. And so doing that all by hand is going to get a little bit tedious. Anyways, it's a little bit of an aside. Right now, we're just going to use the duplicate feature when we need to. So I've created this string of masses. I'm going to create an audio input exciter because I want to do a guitar effect. And I'm going to connect it to this thing. And yeah, that looks good. And then let's connect a microphone. This isn't where I'm going to go, but just temporarily, let's hook up a microphone over here. Let's turn it around. And I think these springs are really stiff. Oh, no, not too stiff. Okay. Okay, let's get some more gain on this thing. Woo! Okay. I think we need a bit more damping. It's ringing a lot. There we go. Okay, so that's something. Not super interesting. Let's see, what would we do? Let's maybe shorten the springs a little bit. Okay, let's maybe a little bit more gain here. I think we're hearing a fully wet signal here. Let's check. Yes, the guitar is off, so this is just the signal coming through Anukari. So we're hearing some kind of reverby, springy type things here. And this is like really customizable, right? We can change the mass of all these things. We can change the spring stiffness. Okay, but I want to see if we can get something weirder than this. And so the idea I had is I'm going to create this kind of zigzag pattern. So I'm going to select this stuff. Oops. Yeah. So you heard it made a big ding when I duplicated that. And the reason is that it just teleported this stuff into existence. I probably should have not copied the connection to the microphone, in which case we wouldn't have heard that. Let's see. Okay. So we have this extra string. And what I really want is to connect this thing here. Now, one thing I could do if I didn't want to hear those types of dings and dongs is I could pause the simulation here. I'm just going to let it run. Actually, no, I am going to pause it because I want to change this into a free mass. And then I want to, not that, create a couple more out here. Is that how I want to do it? Yeah, that'll work. Okay. And then let's add one, let's add an anchorer. Let's stretch that. Okay. Okay. And for this chain, let's set the stiffness to 1,000,000. Let's make them all the same length. Oops. Okay, so now we've created this thing. Okay, and I'm going to do that again. One thing I didn't mention is that if you hold Alt and click something, you get the whole thing. And the difference between that and just, Control A to select all or dragging a box is that it connects everything that's connected. So if I were, for example, to create this thing over here, if I could Alt click it, I get that object or this one. And notice it's only selecting the things that are connected. And sometimes this is really helpful when you're creating things with multiple pieces. Here, it's just kind of a convenient way to select all, I suppose. Okay, so now I'm going to select all, and then I'm going to unselect this. I'm going to copy. Let's see. For now, I'm going to turn the gain down on this mic so all this banging around doesn't make so much noise. Okay, and then let's create an anchor over here. And then let's make that spring a lot shorter. Okay, I'm going to pause again to turn this into another free mass. Okay, a couple more of those. Let's do one more. Turn that into an anchor. Okay, so now we've got this kind of ziggy zag thing. Oop, didn't mean to have that mic. Okay, so I think what I want to do is actually move this mic over to the other end. That, grab this. Okay. Let's make all the springs the same. Okay, let's hear what the guitar sounds like through this thing. Pretty quiet. Let's crank up that gain. All right, that's a lot of gain. What was happening there with that crazy distortion is, to start with, I was playing quietly. The system was sort of vibrating in this shape, but once enough energy was introduced into it, it started vibrating in a bigger way and kind of changing its shape into a different configuration. Let's just tension this a little bit. Okay, I'm going to make this last part of it higher in mass. I think we need a little bit more damping almost everywhere. Okay, and instead of turning up the gain on the guitar input, which is going to cause more of that distortion, which we might want, in this case I don't, I'm just going to turn up the gain on the microphone a bit. Okay, let's change some of the other parameters in here. Maybe let's change these. Let's make these a little bit heavier. Now maybe I'll create another microphone. Let's try moving this one over here. Okay, a little bit more damping in there. Okay, so we got kind of a reverby, sitar-y type thing. Let's do something else here. I don't know if this mic is necessary. Let's create a modulator. Oops, it's way out there. And let's make this thing an LFO. Let's connect it to a few of these. And let's have this modulate their mass a little bit. So you can hear a little bit of pitch shifting there. Okay, this is a little bit interesting. Let's maybe slow down that modulation a bit. Let's move the mic around with a modulator. I think that could be interesting. Okay, now let's try and get something weirder here. So I'm going to turn this mic gain way down. Almost can't hear it. And I'm going to start turning the guitar gain way up so you get a lot of strange stuff happening. So you can see there's a distortion happening there that's due to the fact that this masses and springs are getting way out of their initial positions. And so instead of vibrating in this kind of linear way along these more sort of normal paths, they're getting all excited and creating different shapes, and those different shapes apply forces in different directions, and you get this sort of pitch distortion and other sorts of sounds. Let's go further. A little bit of that distortion is probably coming from the heavy compression, so I'm going to turn down the mic gain just a little bit more. Okay, so that's getting kind of out there. Let's get further out there and let's modulate this mass even more. Let's move the mic in a weird way. Okay, well, that's probably enough really weird stuff for the day. Hopefully, now that I've kind of gotten things set up with the cameras and stuff, I can do more demos of building instruments and audio effects. But anyways, thanks for watching. It's fun to build that kind of strange guitar effect instrument. I'm not sure what to make of it, but you can kind of see what sort of stuff is possible with this user interface. And with a lot of time and effort, you can tune these things and make some pretty interesting effects. So I'll just talk for a minute about what's coming up in the future. So I'm really happy with the progress I've made with Anukari so far, but there is, like I said before, a ton of work to do. There's a lot of physics features that I want to do. For the modulation, there are things I want to do, adding new types of modulation like envelope followers, better integration with DAWs and their parameters and stuff like that. Obviously for the LFOs, we need all the stuff that you expect, like different triggering modes and syncing and that sort of thing. In the near future, I'm going to start adding delay lines. I think that adding delay lines as first-class things in this world could be really fun. So you could pipe in audio from an instrument and then also pipe it in with different delays, pick up audio from the system, and then pipe it back into itself as a feedback effect with zero delay or more delay. I think that we'll be able to get some really interesting results with that. All of the different objects in the world, I want to add more parameters for. So the springs, I'd like to add different types of nonlinear springiness, maybe, nonlinear parameters into the springs. Different microphone models. The model's pretty simple for mics right now, but there's a few different directions I could go with it, and I expect to make that configurable so there'll be different types of microphones you can use. I may eventually add some simple collision stuff so you can have collisions between masses in a fairly constrained way, but at least then you could get some sort of more vibrating kinds of sounds, or not vibrating, but rattling, I guess would be sort of more the right word. And then, the user interface is really, I think, where going forward over the next few months, a lot of work is going to go. Like I said before, I want to add that duplicate mini feature. But in general, I just want to make it less utilitarian and more nice to use. That'll include making the 3D graphics better, paying an artist to help me make really nice models, make the animations more interesting, make the graphics tell you more about what's happening in the simulation. As well as making the things just more usable. I'm pretty happy with the way this right panel editing works. You can select multiple things, go in and edit their things. But I think there's more that could be done here. It also could look nicer. I think there's more innovation I can do around how some of these parameter editing things work. One thing I didn't go into today, and maybe I'll do this in a future video, I didn't really go into tuning an instrument. I made an audio effect for guitar, but I didn't show making an instrument that, is designed to produce particular pitches so you can bang on bells or whatever, making certain sounds that you want. And today you do that by, if you're using Ableton, I'll often use the built-in Ableton tuner. So if I let this go, you can, if I pluck this instrument, it'll have some pitch. Oh, it's heavily damped. But you can use the Ableton tuner to do this kind of stuff. But eventually Anukari should have a built-in on-screen tuner. But more importantly, I want to add an automatic tuning system where you can tell Anukari, here's a microphone and here's an exciter. Please, make this all sound like an A. And that way, when you duplicate MIDI, you could create a whole bunch of something, tell it to automatically tune it to chromatic scale, and then you can play that instrument on a keyboard without a lot of work tuning it yourself. Yeah, and then there's a bunch of other stuff that just has to happen. I'd like to have MPE support to have like really powerful MIDI control over Anukari, things like that. Right now, Anukari only runs under Windows. In the audio world, it's pretty important that it also runs under Mac. That's something I'll do. I haven't decided yet whether I'll release the Windows version alone first, or if I will try and work on the Mac support and release them both at the same time. That's something I'd love to hear from folks in the community about. I'm not sure how many people are going to want to use Windows and how many people are going to want to use Mac. There's a lot more to come, but thanks for sticking with me. It's a long demo video. Hopefully there's some stuff here that was interesting to you. And please, bring me your questions and thoughts and ideas and all that kind of stuff. Thanks a lot.